Hi, everybody, and thank you for joining us for our webinar today, Optimizing Insulation System Design with Mastics and Facings. My name is Kim Melton, and I will be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. If you have any questions throughout the presentation, you can submit them to our panel via the Q&A feature, and that should be showing up on the right side of your screen. We'll address these questions live at the end of the presentation. Now, if you don't see Q&A to the right of your screen, you can actually look for the series of circular icons at the bottom center of your screen, and you select the icon with the ellipsis on it, and that will open a menu with an option with Q&A at the top, and you select that option, and it will open the dialog box to the right to submit questions to the right of your screen. Additionally, we're going to follow today's webinar with a survey. This is your opportunity to provide us with feedback on how we did today. You can ask any additional questions you may have about the topics we discussed, or even suggest new topics for webinars you'd like to hear in the future. We're continuously striving to improve and evolve these webinars, so if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like we've missed the mark today, we'd encourage you to fill out this survey, and we use your feedback to improve our webinars and provide the information that has the most value to you. Now, this survey is also part of how we deliver the JM experience to you. And the JM experience is based on 4 pillars of the JM culture, and that's people, passion, perform, and protect. And we believe it's critical to make sure that we hear and understand and respond to your needs in order to deliver the best interaction to you. So we offer webinars like this one to help educate the market and offer a tool and a resource for you and your business. But this isn't just a one-way street. So your feedback is a key component to helping us evolve to better meet your needs. We're also frequently asked whether or not we send out these presentations, and upon their conclusion, we don't do that, but while we do actually send out a recording of the presentation afterward, and that ensures that you can have it within its full context. So with that, let's dive into some introductions. Joining me today are Scott Witherow, Brennan Hall, and Lance Bonin, who are going to kick us off. Scott, go ahead.
Thank you, Kim. Good afternoon. Good morning, everyone. My name is Scott Witherow. I'm Vice President at Design Polymerics. I've been in the sheet metal, duct sealant, duct liner adhesive, insulation mastic business for 32 years. The last 18 years has been with Design Polymerics. I'm currently on the board of directors of the spiral duct manufacturers. I helped write the UL 181 codes for duct sealing, and I currently consult with several industry organizations on duct sealing. Design Polymerics, we manufacture high-performance green building products, and we've been doing that for 33 years. When the original U.S. Green Building Council LEED program started in Washington and Oregon, they chose us because of our green building capabilities. We have the only line of independent lab-tested zero VOC water-based duct sealants and insulation mastics. We also have very low VOC duct liner adhesives and low VOC solvent-based duct sealers, as well as a new line of zero VOC rolled butyl mastics.
Oh, so I am Lance Bonin. I am the mechanical insulation portfolio manager. I've been with Johns Manville for 19 years and have been in the mechanical insulation business for 19 years as well in various roles.
And my name is Brennan Hall. I am the Senior HVAC Product Manager for Johns Manville. I'm responsible for duct wrap, duct liner, and duct board products. I've been with JM for 4 years, about 11 years in the HVAC industry between manufacturing and distribution. I also am a Spiral Duct Manufacturers Board member with Scott. I am our SMACNA Premier Partner Liaison, and I also am on the NEMA Air Handling Council. And with that, today we have a very exciting and a terrific joint webinar that we've set up for you guys. We're excited to have Scott Witherow here today from Design Polymerics, and hopefully you guys will learn a lot from today's webinar. So a quick overview of what we're going to cover today. I'm going to kick us off with basically just understanding some basic duct system requirements. I'm going to pass the ball off to Scott, and he's going to go into sealants and sealing the duct systems. It'll come back to myself and Lance, where we'll talk about duct facing and material selection relative to your duct system. Lance will dive into insulating chilled water systems, and then Scott will come back and kind of round us out with using mastics to seal those systems as well. So a full lineup of topics for you guys to discuss today. So the first thing that we're going to go into is understanding duct system requirements. So there's several design considerations when looking at duct systems that are important to consider as you begin to specify and design your ductwork. The first thing is probably, or most important, or one of the most important features is temperature control, which makes sure we are delivering the conditioned air at that desired temperature to keep the building occupants comfortable. The second is acoustical control, which makes sure we're minimizing overall system noise, crosstalk, fan rush noise, anything like that that causes acoustical problems in the system. The third thing is energy conservation and making sure we're taking the needed steps to save the building owner the maximum amount of dollars for that system. Condensation control and mold growth, obviously making sure we're taking steps to mitigate and control moisture, which prevents that mold growth happening in the system. Making sure that your duct is code compliant as well as specification compliant, making sure we're delivering things that are needed in the marketplace from a code standpoint, meeting duct construction standards, whether it be SMACNA or something else, to make sure we're doing it properly. Fire safety, building life, and occupant safety is very important right now, making sure that we're designing the system to mitigate those risks in the duct system. And then last is durability and integrity of the system, making sure that you are producing a system that lasts the lifetime or the lifespan of that building. So looking at the ideal duct system, so these basic kind of design considerations all build your systems towards the ideal duct system. And some of those main characteristics of an ideal duct system are making sure that the conditioned air is remaining constant down through the length of that HVAC system, making sure that that fan or air rush noise, crosstalk noise is not transmitted through the ducts, that making sure your duct system is sized and designed to maximize the unit's performance as well as providing optimal energy savings. You want to make sure that your duct is designed to provide the required airflow to those occupied spaces. And last but not least, and probably one of the most important things with a duct system is minimizing leakage or making sure no leakage of the conditioned air or return air is lost. So with that, I'm going to turn the ball over to Scott Witherow of Design Polymerics, and he's going to go into the importance and discuss sealants and the importance of sealing ducts. Scott, it's all yours.
Thank you, Brennan. The need for sealants. The most important is energy efficiency, and energy efficiency translates into cost savings into money. Typical commercial system, even with a contractor's tightly fitting duct, is typically 10%, usually greater, of unsealed duct. And on the residential side, it's closer to 25%, and quite often much more than that. The Department of Energy did a study in Florida, and this was back in '94, and found that the most cost-effective way to save energy, one of the most cost-effective ways, is to seal the duct system. The estimated annual cost of a CFM of air is $1.75 a year. And when you're talking a $12 gallon of duct sealer, it pays for itself very quickly. Health and safety are another concern with unsealed duct. Air leakage in return air and sealing spaces in wall cavities can lead to infiltration. Basically, you don't want to breathe what's behind the walls and in the attic space. Unsealed duct can also lead to condensation. Condensation can lead to mold and mildew growth, and certainly a very big concern of building owners and occupants. Code compliance. We can almost have a full webinar on this, but the important thing to know is the requirement for duct sealing. I'm sure most people on this webinar have seen an increased requirement for duct sealing. You will see a lot more of it in the coming years. The codes and the regulations are becoming more and more stringent, and the requirement for lower VOC and emissions test sealants that passed emission testing are becoming more and more relevant. Types of sealants. There are basically two types of duct sealants, water-based and solvent-based. When I first started in the business, 90 to 95% of the duct sealant was solvent-based. Over the years, there's been tremendous increases in the technology and the quality of water-based polymers, and now that's almost flipped. We're seeing 90 to 95% water-based and the remainder solvent-based. We're going to spend most of today talking, or I'm going to spend talking about the water-based side of the duct sealants. The advantages, the benefits of water-based duct sealant, compared to solvent-based, they're lower cost now. They're about half the price of the solvent-based duct sealer. Years ago, they were twice the price, but again, with the technology, they're about half the price. They're non-flammable, they're little fumes, cleanup's easy, they're very flexible, very easy to spread, and most water-based duct sealants are very low VOC. In the case of design polymerics, DP 1010, 1015, 1020, 1030, there's zero VOC. Water-based duct sealers quality. We're going to dive into this a little deeper in the upcoming slides, but I do want to emphasize you cannot tell quality of a duct sealer through the literature, the SDS, a UL 181 listing, water or solid content, viscosity, and we will be walking you through the features of good quality sealants and the trouble you can get into by not using a quality sealant. Water-based duct sealing dry time solutions. I wanted to include this in the presentation, although I'm not going to spend very much time on it. I got asked this question so often, I decided to write an article for SNP's magazine and last month's edition. You can see a link to it at the bottom. Essentially, shops are fabricating duct with sealed seams with water-based sealant and water-based duct liner adhesive to adhere the duct liner. It has created moisture and curing problems because the water has nowhere to evaporate. I have solutions and different strategies for eliminating this problem. Again, the website is there for those who are interested. The benefits of solvent-based duct sealant. The real benefit of solvent-based duct sealant is you can use in unfinished buildings in freezing temperatures during the winter. Most solvent-based duct sealers will continue to cure below 32 degrees. Our DP 1090 is a low VOC solvent-based duct sealer that you can actually apply the sealant at 0 degrees and below without breaking a caulk gun, and it's still spreadable. One of the other benefits of the solvent-based sealant is on older spiral machines. A lot of times there is a lot of oil that's used to push the metal through the knurls. The solvent-based tends to cut through that without a lot of cleaning. There are large variations in VOCs within the solvent-based. DP 1090 again is 44 grams per liter. There are many out there in the 400, 500, 600 grams per liter range. So keep an eye on that, please. The drawbacks, and again I'll go through this quickly since it's such a small part of the business. The cost we discussed, the cleanup, not nearly as easy as the water-based. You have the odors and the flammability issues and the storage handling as you do with any type of solvent-based product. Duct sealant characteristics. The most critical factor when determining whether your duct system is going to pass a pressure test or if you specify a good quality sealant is using the correct sealant. We're going to go through some of those characteristics in the following slides. The characteristics that you're looking for in a duct sealant is flexibility, cohesion, adhesion. We'll address the solid content, viscosity, some of the myths there, water resistance, and briefly touch on some of the UL 181 codes. The most important aspect of any type of duct sealant is flexibility. Flexibility is key. Duct system has vibration that goes through it. When the fan comes on, it creates a pressure. When the fan turns off, that pressure decreases, causing the duct to expand and contract. In the heating or cooling mode, long runs duct system will actually grow or shrink. What you need is a water-based, in this case, a water-based duct sealant that will move with the vibrations of the systems. We're going to talk about this a little later. A sealant that is not a high concentration of polymers, which is rubber and glue, will be flexible. One that uses a lot of filler will be rigid and will not be able to hold up to the movement of the duct system. Adhesion, cohesion. Adhesion is the ability of the sealant to stick to the metal. Cohesion is basically how strong that film is when the duct starts moving. The cohesion is definitely close importance to the, and goes hand in hand with flexibility. As the duct system moves and grows, the sealant needs to be strong enough to hold together. If you have a sealant that has poor cohesion strength, it'll actually lead to tearing or cracking of the film, which leads to air leakage. And again, a sealer with a high polymer content will give you good adhesion to hold up to that movement. A filled, cheap economy sealant, you won't get that type of forgiveness. Solid content. And the reason I have this on here is kind of a warning, and it's one of the most common things I run across, both with contractors and with engineers. Solid content is not a determination of whether a sealant is a quality sealant or not. An 85% solid content that is filled with clay or calcium carbonate, ground up drywall, is going to be a poor duct sealant. A solid content of 70% that is mostly polymer, rubber and glue, will be a good flexible sealant that'll pass pressure tests. You cannot tell by looking at a data sheet and a solid content whether a sealant's going to be a quality sealant or not, just by looking at the solid content. Viscosity. This goes hand in hand with the numbers on the solid content. Viscosity does not tell you anything about the quality of a duct sealant. High or low really doesn't matter. It's the way that it applies. There are two types of water-based duct sealant. They're smooth or creamy duct sealants, and they're fiber-reinforced duct sealants. Whether it's fiber or creamy really doesn't play a factor into how good a quality a sealant it is. The fiber reinforced is essentially 1% fiber used to thicken up the products, which allows it to fill holes and gaps easier. The creamy or smooth duct sealer applies easier, goes on smoother, the installer gets better coverage, and the choice is based on preference. Duct sealant application and troubleshooting. The most common sources of leakage. The most common error or source of a failed leakage test is user error. And we're going to go through that in the upcoming slides, some strategies of properly sealing a duct system and how to look, how to troubleshoot some failures. I have a list of additional or important things to look at, especially with projects that require 1% system leakage. I'm not going to go through them all, but pay particular attention to fire smoke dampers. Do not seal those without consulting the manufacturer. However, when you do seal the connection to the duct, make sure your duct sealant has been tested to UL 555, and that's for the connections, not for the sealing the actual damper itself. And our DP 1010 has been tested to UL 555. Additionally, a big source of leakage is VAV boxes because of the nature of their construction. There's typically a lot of holes and punch-out areas that can significantly lead to leakage, and those are easily sealed with water-based duct sealant. A couple things that I've noticed over the years and to keep an eye out on or to be careful of, caulk sealants that are laid down on duct. And this goes for water-based or solvent-based, can sometimes float on the thin layer of oil of galvanized steel. Backbrushing those caulk joints and breaking that thin layer of oil is always a good idea. Especially with water-based duct sealants, make sure it's protected from water while it's curing. Rain, condensation, transporting on stake body trucks can all cause the water-based duct sealer to wash off before it's cured. Also keep an eye out that and be aware that not all duct sealers are recommended for outdoor use. There are a lot of duct sealants out there that are not water resistant, meaning after they are cured, they can run off the duct. If it gets wet, they can reactivate. Design Polymerics, we use a product called styrene acrylic, and that's commonly used in roof coatings. And we are well aware of the issues that water can cause on water-based duct sealants, even after it's cured, and we have addressed those issues. Application, we'll be going through the first four bullet points. There's a lot more to this. Again, I got so many questions. I wrote a couple of years ago an article for Snips magazine, and it addresses how to pass a 1% leakage job, and it's got some good strategies in there for you. And further on, I'll have a checklist, again, for troubleshooting leaking duct systems. Again, another common question I get is how thick you should apply the duct sealant. Instead of saying mill thickness, which UL requires on our data sheet, it's a good idea to look for nickel thickness. You certainly don't want to get it too thin, and that is a very common source of failure, especially on some leading edges, which we're going to talk about in the next slide or two. A duct sealant, the paper thin or thin enough where you can see through it, is not going to be able to hold up to vibration and pressure. Not nearly as often, but too thick, more is not better. Slapping a duct sealer on a half-inch or an inch thick can cause you problems as well. Some application tips, and this is what I was alluding to in the previous slide. It's very important that you apply duct sealer in the correct direction. And when I say correct direction, you don't want to take a brush and try to seal both seams of a slip and drive system with one passing. What happens is that leading edge of the slip will end up with that paper thin sealant, and you end up trying to bridge that gap. So when I say direction, ideally what you do is you brush or caulk the duct sealant into the seam and try to push it into that gap, and that fills that gap and ensures a good seal. Same is true on the hammered over edge on the drive cleat. Don't brush over it, brush into it. You want to make sure that sealant gets underneath there. By brushing over it, you basically cut into the sealer. Again, you end up with that paper thin duct sealant rather than some duct sealant filling that gap. Another application hint tip, installers, when they put the gasket tape on the 4-bolt connection, whether it's TDC, TDF, or any of the applied flange, they're putting that gasket around and they're getting a nice seal along the face of the flange. Oftentimes that corner gets forgotten, each one of the 4 corners in the rectangular duct. A little bit of duct sealant or gasket tape, a little piece of gasket tape that's snapped off, wadded up, and shoved into that corner is critical on passing some of the stringent duct sealant requirements. For the Pittsburgh seams, sometimes a non-curing butyl sealant is injected into the lock before it's hammered over. And quite often, since it's a non-curing butyl sealant, it never cures and it can get messy. The operators tend to start it late and end it early, so they don't have any mess, and that's definitely a source for air leakage. On 1% jobs especially, make sure either on the inside or the outside that you brush or caulk duct sealant along that seam to ensure you get a seal. I also recommend, if you see on the far right top, putting a little dab of duct sealer into that seam, and that prevents air from traveling along that seam and trying to find its way out of the duct system, and do that on both ends. Spray application for the right contractor is an excellent way to pass pressure tests. Spray is applied by an airless sprayer, and it hits the duct with a velocity, and it forces the duct sealant into the seam. So, and it forces it way back into the seam, allowing you to get a very tight seal. We have a product, DP1010 spray. It's zero VOC, but very high viscosity, which means it doesn't splatter, it doesn't drip, it doesn't run. For the right contractor, it's big labor savings on the application, and also for resealing the duct. The larger the duct and the straighter the runs, whether it's round or rectangular, the labor savings goes up tremendously. Although we do have a large number of folks that are spraying 4- and 6-inch round from the inside. Duct leakage testing. This one again could be a webinar unto itself, but I have a checklist available to walk you through the different ways to troubleshoot both the duct system and the equipment itself. The first thing, if you do not pass a pressure test, is to make sure the operator knows what they're doing. And then to make sure the equipment is in good working condition with no clogs in the manometer, and to make sure the orifice tube matches the chart and make sure it's fully calibrated. Again, I've got a full checklist that will walk you through leakage testing, along with all the sources of leakage that'll be available to you. And just very briefly, I've had this happen a number of times, less recently, a lot in the past, where an inspector would come through with soapy water and start brushing it on and say, hey, you've got, Mr. Contractor, you've got air bubbles, and you're not passing leakage testing because I'm doing a soap bubble test. I'm not going to go through the math with you, but 212,000 soap bubbles per cubic feet is a lot of soap bubbles. So this is information for any contractor that gets caught in that situation. Here's a little bit of backup to help you out.
All right, thanks, Scott. A lot of great information there. So now that Scott's cover the need for sealing the system, it's going to be time to select the facing that you're going to use for your external duct insulation. So in this section here, Lance and myself, we're going to cover the different types of facing and the importance of selecting the proper facing for your external duct insulation. So heat and moisture basic concepts. So the first step to identifying a facing is understanding the need for the facing or the vapor barrier. So on the left-hand side of the slide, we see an example here of a basic heat concept, and the figure illustrates how the transfer of thermal energy moves from a high temperature space to a low temperature space. The figure on the right-hand side of the slide shows how moisture or water vapor moves. Water vapor, or the transfer of water vapor, typically moves from an area of high water vapor pressure to an area of low water vapor pressure. So making sure you're managing the flow of heat and moisture will really determine the success of that insulated and sealed duct system. Controlling condensation. So now that we've covered the basics of heat and moisture flow, let's talk a little bit about condensation control. Controlling temperature and condensation will really help prevent mold and fungus in your system along with sealing it. Here in this example, you see a duct space here where you've got 55-degree air coming off of your fan, blowing down about 100 feet of bare sheet metal duct. It loses about 10 degrees or gains 10 degrees once it reaches the occupied space without insulation. And in that 80-degree plenum space, if in this scenario, any plenum with relative humidity that's above 45% will pretty much result in condensation. So therefore, making sure you select an insulation with a proper vapor barrier is very key to controlling your condensation, and making sure that duct system is sealed will also help you in this scenario. So understanding perm rating, so facings or vapor barriers effectiveness are really measured or expressed in what we call perms, or a permeance rating. So what is a perm? A perm is basically a water vapor flow rate of 1 grain of water passing through 1 square foot of material in 1 hour. We basically classify these different types of vapor retarders through 3 different classifications. Most vapor retarders in the insulation business, such as your foil scrim crafts or your PSKs, things like that, are impermeable vapor retarders. They are less than a 0.1 perm rating. There's other things that are semi-permeable, which is anywhere between 0.1 and 1, and then class 3, which is a permeable vapor retarder, and we'll talk a little bit about more what those examples of those are in some of the subsequent slides here coming. So where to place your vapor retarder? So it's really important that now that we've talked about controlling condensation, understanding where that vapor retarder goes relative to your insulation, and you want to make sure that the vapor retarder is always facing away from the duct or the system or the piping that you're insulating, and that'll help mitigate the condensation from forming between the duct itself or the piping and actually the vapor barrier. So you want to make sure that you turn that vapor barrier away from the system that you are insulating for best results. Some of the different examples of vapor barrier or vapor retarders that are out there, if we'll start at the bottom and kind of work our way up through this chart. So our standard jacketings or FSKs, our ASJs, they are considered impermeable vapor barriers. They're down there at the very low ratings, or polyethylenes. Craft paper facing is also considered a semi-permeable facing on things like bats and rolls, things like that. As you move forward and you hit like your latex paints or concrete blocks, those are things that are pretty permeable, and they don't do a great job of mitigating moisture transfer. And then things like gypsum board, which has a very, very high perm rating, is something that you really wouldn't want to use in a situation where you're looking to control your condensation on something. So as far as vapor barriers, and we're looking at the different types of options for vapor barriers that are out there, and typically in fiberglass insulation, your standard facing is what we call FSK, or foil scrim craft. It's basically 3 components, which is a layer of aluminum foil that is laminated together with a scrim reinforced fiber, as well as a layer of craft paper, and those are all laminated together into a composite, which are then in turn glued on during the process of creating fiberglass to create something like the picture here, which is our Microlite FSK duct wrap. That facing has a 0.02 perm rating, so very good perm rating or permeance does a great job of stopping condensation and controlling it. And what's interesting about the facings for JM, at least our FSK facing, is that we manufacture all of those facings for FSK in-house. at our facility just outside of Richmond, Virginia. So we're able to control all the components of our fiberglass duct wrap, for example. We make the fiberglass, obviously, but we also make that reinforced foil scrim craft composite, which is a really nice thing for us to be able to control that quality and deliver a quality product out there to the market for you guys to use to control condensation. So another type of facing option that we have, we offer a white PSK facing, which is a poly scrim craft or a metallized polypropylene that is laminated together into that same composite with our scrim reinforcement and a base layer of craft paper there. That's then in turn glued onto the fiberglass during the production of our duct wrap. Our Microlite white PSK product, we launched that in 2015. It's really a nice aesthetic option. The idea behind it is the white facing itself matches adjacent pipe coverings, walls, ceilings, things like that. So as we kind of continue to see this trend of open ceilings and open looks in a lot of the buildings that are out there today, it really does a nice job of kind of blending that all in and giving you a nice white, clean, finished look that's easily cleanable to use in your building. And I'm going to take that opportunity. We're getting ready to launch a new product here at Johns Manville that's coming soon, and that's going to be our Microlite Black PSK, which is that same polypropylene reinforced scrim facing, but it's going to be black in color. So kind of the same reasons as the white, the aesthetic nature of the product. You see a lot of the open ceiling trends that are happening out there today. But we get a lot of requests about painting our FSK facing, and typically they're asked about painting it black. What happens when you paint your facing is it basically voids your UL warranty on that product. There's a 2550 flame and spoke spread rating that all of our facings are tested to, and once you decide to paint that, it voids that warranty because we don't know what you're painting that facing with. It could be very flammable. We don't know what that is. So we've decided to go ahead and move forward, and this will be a facing. We're planning on launching this product about June 1st, so we're about 6 weeks away, and there's going to be a lot more information coming down the pipeline for you guys too that'll come through your email as we get closer to the product launch. But this is something that we think will be very beneficial out in the market space and be very helpful to the contractors and design of the buildings moving forward. Another facing option that we have is our Microlite Standard Duct Wrap Vinyl Facing. Has a little bit higher perm rating, as you can see, 1.3, so it's not near as good as what your FSK or your PSK facings would get. It's a very multi-purpose kind of product that gets used in a lot of different applications. We've seen it used for removable valve covers. Some people will use it on some duct insulation. I've seen it used in chicken coops. It's a very, very kind of multi-purpose clean face with a little, the vinyl stretches a little bit more. It doesn't have that reinforcing scrim in it, so you can kind of pull it a little bit. In places where you might need something that's white or a clean look, something that's cleanable as well. So just another option that's out there that we offer as a facing. So tape. So I'm letting the cat out of the bag here. I'm giving you guys, thank you for attending. You're getting to see all some of the new stuff coming down the pipeline with us. But tape is extremely important, especially for duct wrap. And when we launched our white PSK product, probably the most common question that I received was, what tape do I use for your white PSK duct wrap? And there's lots of different options out there, but nothing that was a perfect match with the sheen and the color, the scrim pattern, the whole 9 yards. So we are going to launch a white PSK tape as well as a black PSK tape here. We're going to be ramping that up about June 1st, 6 weeks out or so. The same with the timing of our black PSK duct wrap. The tape is going to be a 96 millimeter, so about a 4-inch wide tape. I'm not going to do a 72 millimeter tape. It's a much better finished look, and it's a really aesthetic application for the product itself, and that 96 millimeter really does a nice job of closing and sealing that seam up. So again, more information will be coming about these products. We'll be updating the website. We'll be sending out a product blast, but more to come on this, but a really nice addition to the product offerings that we have for sealing and matching our facings. So with that, I'm going to pass it over to Lance Bonner, our mechanical portfolio manager, and he's going to take you through some of the facing options that we have for our pipe insulation as well as our mechanical board.
Thanks, Brennan. Like the fiberglass duct wrap, fiberglass board products from Johns Manville have several facing options. Similar to the duct wrap, there is a FSK facing available with our board products. This is that foil scrim craft composite. And the foil on the outside layer of this facing is what's providing the vapor retarder. Johns Manville has a couple ASJ or all-service jacket style facings. The first one is AP. This is a white bleached craft paper facing with the fiberglass reinforcing scrim and foil on the inside or facing the fiberglass for the vapor retarder. Coming out in the next few days, we are launching an addition to the 800 series fiberglass board line. It is a facing that is an ASJ facing. It's similar in terms of application, but the composite is different. It has a polypropylene exterior, and it does have the same scrim reinforcement, uses a metallized polyester on the interior layer to create the vapor retarder. So in all three cases, the performance on these products are similar in that they have a 0.2 perm rating, so quite good for slowing the moisture drive that could be present in a system. So let's spend a little time talking about chilled water systems in particular. Chilled water systems, there needs to be a number of considerations taken in when you are designing those types of systems. One of the most important things is to make sure that you're preventing condensation, and we'll spend some time talking about that. But there's a couple programs, or a program listed, the NAMA 3E Plus program, and a reference from ASHRAE 90.1 that can help in determining how you would go about preventing condensation. Another factor is making sure you have a vapor retarder present. Regardless of the insulation used, a vapor retarder is critical for a chilled water system. Whether you have an open cell or a closed cell insulation, the vapor retarder keeps moisture or slows dramatically the migration of moisture into the system, which is critical for keeping the insulation performing well. This is especially important with fiberglass as it is an open cell type of insulation, and it is somewhat susceptible to moisture drive, so that vapor retarder is critical. The understanding what type of conditions the system, the insulation system is going to be experiencing is a design consideration. You want to make sure that you're giving the insulation system the proper protection to make sure that it performs well over time, and if there is any type of maintenance or repairs required, that's taken care of. Again, those vapor barriers keep moisture out of the systems, and they need to be maintained and sealed at all times. You also want to make sure you're using an experienced and established mechanical insulation contractor. They're going to understand the specifications that are used for a chilled water system, and they're going to have experience in practically installing these systems, and they can also help troubleshoot. So if they notice something about the specification in particular, or perhaps during the installation itself, they can help prevent an issue down the road. And finally, you want to make sure you are writing a well thought out specification that is designed specifically for chilled water. There are a number of important factors that go into that, and there is an excellent guide with NAMA for chilled water piping, and of course Johns Manville has an InsulSpec specification that could be copied on our website. Finally, NAMA is creating a new program, so NAMA being the National Insulation Association, they're creating an inspector program. So if you include that as part of your specification, you can have a certified inspector come along and make sure that the specification that was written was followed during the installation. So let's talk about some of the specifics. Brennan talked a little bit about vapor pressures, but some additional information would be, to think about the conditions that your system is going to be operating in. So if you have a very high temperature, high humidity situation, something tropical in nature, you're going to get a high vapor pressure area. Say in this example, it's over 1. When you compare that to a commercial office building, which has far less strenuous conditions, you would probably get a lower vapor pressure. In this particular example, it's 0.4. But if you compare that to the conditions right at a chilled water system, say that isn't insulated, you could have a vapor pressure that's quite low, so 0.19 in this particular example. So in the case whether you're in the tropical conditions or in an office, in both cases, the conditions are going to try to drive moisture into your insulation system. So it's a critical thought that needs to be considered is to keep that temperature above the dew point, which we'll talk about in just a second, and that the vapor barrier is intact to keep the moisture from driving into your insulation. So in terms of preventing condensation, you're really looking to make sure that the air, which has some moisture in it, doesn't reach a temperature where that moisture is going to go from a vapor form onto a liquid form, which is really the definition of condensation. And you do that by keeping the surface of your insulation of the system above the dew point. So some really critical factors to think about is, what will the air temperature be? What are some likely humidity conditions? And then what will be the temperature of that operating system? You probably want to think in terms of what are some of the high stress time periods that the system will be under, and kind of plan to those higher temperature or higher stress situations. And we'll talk about it in a minute, but there are some additional guides that can help on figuring out what that exact scenario is for your particular situation. So you've, and here it is. This is actually the 3E NAMA Plus program. This has a function in it that will give you, for your specific situation, the required insulation thickness will prevent condensation. It also has a number of other features that may be of interest, things like managing heat gain and loss, thickness for personnel protection, energy savings, or even carbon footprint. That's on the NAMA website, or you can contact Johns Manville. We can work that with you to your particular situation. Specific to preventing condensation is really understanding what the insulation thickness needs to be for the particular situation to prevent that condensation, or keeping the surface temperature at that insulation above the dew point. So that's the effect the insulation has there. It tends to keep that insulation closer to the ambient temperature and keeping it closer to the warm conditions that the ambient air is, rather than allowing that surface temperature to approach the chilled system where it's much more likely to condensate. And then once you've got the specification determined for that thickness, you have to make sure that the conditions allow for that insulation to maintain its thickness in all the areas that it could be installed. So that's where your contractor can help you identify or troubleshoot some concerns if there's a risk of not being able to maintain full thickness. Again, as mentioned earlier, the vapor retarder is critical to keeping the system running well. There's a couple ways to ensure that if there is a jacket puncture or seam that it is sealed up. One is to use a tape that has the same perm rating as the facing, or you can use Mastics as well. Those, again, need to be at the specified perm rating requirement for that system. And just a couple facing options that are available with Johns Manville's pipe insulation systems. We have an ASJ jacket or a Microlock HP. This is, again, a white bleached craft paper with a fiberglass scrim reinforcement and foil on the interior layer, giving you your perm performance. We also have our Microlock HP Ultra, which is a polypropylene exterior with that craft paper, scrim reinforcement, and again, foil providing you the perm rating. So in these particular cases, HP performs at a perm rating of 0.02, and HP Ultra is at 0.01. Turn it over to Scott, and he can talk about Mastics.
Chilled water piping insulation Mastics. If you'll notice, I've got in bold and underlined and with an exclamation point, check your perm rating. Lance talked quite a bit about 0.02 perm for chilled water piping, and that's a requirement by NAMA. And DP3040, that's pictured on the right, does have a perm rating of less than 0.02. The reason I say check your perm rating is several major manufacturers have changed their formula in the past 6 or 8 months to make their product whiter. Their Mastics at one time did turn yellow, did turn brown, would streak, and it wasn't that big a deal when it was against a craft paper or ASJ. With the newer introduction of the polypropylene type jacketing, like the HP Ultra, that is a lot whiter and a lot glossier than old jacketing. The yellowing, the streaking, the browning is really pronounced. The problem is with the reformulation to make their sealants whiter is that the perm rating is well above what is allowed for NEMA for chilled water piping. The perm ratings have gone from 0.016 to 0.05 to 0.09, and again, that's well above what NEMA allows. Our DP3040 has a perm rating of less than 0.02 when tested with ASTM E96, whether it's method B or method D. And in addition, you get the benefit of zero VOC and the newest lead version 4, which is emission testing. So check your specifications, and I would say check your submittals. But check your submittals online. The old submittals will have perm ratings that meet the requirements. The newer ones very well may not meet the current requirements of NEMA. So be very careful, especially for a contractor and for an engineer. You don't want to put on a product that is not proper for chilled water piping. A rule of insulation mastics rules of thumb, and I'm going to paint this with, pardon the pun, a very wide brush. Anything inside the building envelope below the roof, typically vapor barrier mastics are used on pipe insulation. You definitely have to use it with chilled water piping insulation. But most contractors will use the same product to seal all the pipe insulation, rather than having two different type of mastics and trusting that the right mastic would be used on the right system. And again, that's a general rule of thumb. Lagging adhesives are used with exterior duct wrap. They tend to be lower cost than the vapor barriers. They're vapor retarder. The delta T, the temperature difference between the duct and the ambient, is a lot less than the delta T between chilled water piping and the ambient. It doesn't need to be as high performance as a vapor barrier does. Design Polymerics has our Zero VOC DP3050, and it is available in black for the new Microlight Black PSK that JM will be introducing. Outside insulation, when you are using mastics, a weather barrier, and I like to always refer to it as a breather mastic, should be used. The whole concept when using mastic outdoors is that water some way, somehow is going to work its way underneath the insulation. That water sometime during its life is going to turn into a vapor. That vapor is going to create a higher pressure underneath the insulation, and it will allow the water vapor to escape through the breather mastic, hence the name breather mastic, and allow that moisture to escape, hopefully preventing or helping to prevent corrosion under insulation. So just general rules of thumb, vapor barrier mastics are used in the building envelope below the roof. Lagging adhesives are used on duct wrap when tape is not used. And breather mastics, weather barriers, are used for outdoor applications.
All right, thanks, Scott. With that, I'd like to take a few minutes to talk about an online resource we offer at JM called The Source. And in your chat, you should be getting a link to that right now. This is a free portal that you can use to access our educational information like blogs, online training, tools, product documents and specifications, that sort of thing. Additionally, this is where all our recorded webinars are hosted and where we will be recording or posting the recording of this webinar today. When today's webinar is live online, we'll send you an email with a link for direct access to that webinar. So if you'd like to visit the source today, Dana sent you a link in chat to the HVAC and mechanical source portals, and you can also find links to them online on the HVAC and mechanical home pages on the JM website. For anybody who attended today, you are going to receive a certificate of completion by Friday after the webinar, and that can be submitted for professional development hours. And again, this is going to be sent to you via email, and that'll be in your inbox on Friday. With that, let's take it to some questions. We had some good ones, and to start off, we have a softball coming to you, Scott, and that is, I know what JM is, but what does DP stand for as an abbreviation?
Very easy, Design Polymerics.
Excellent. This next one is a pretty unique question, and that is, I got involved in a project where duct work was sealed after the air systems were started, and the work was done during the day when the systems were operating. What are your thoughts about sealing the system while it's in operation?
So again, this is Scott Witherow from DP, or Design Polymerics. It's not a good idea. Duct sealant needs time to cure to create a film strength, and that goes whether it's water-based or solvent-based. Any type of elevated pressure will blow that sealant out of the seams. There is a solution, however. I mentioned briefly and early on of what's called a foil mastic tape. It's a 15 mils of cured butyl with a 2 mil foil backing to it, and it's a completely cured butyl. It's got great grab to it, and you can apply it while the system's running. Very much like a duct tape, but obviously much thicker. You take what's called a squeegee and you press it onto the metal, and there is a way to seal a duct system with it running. Commonly done in occupied hospitals. There's not a good solution for a brush-on or caulk-on sealer to apply while the system's running.
Excellent. Thanks, Scott. Our next question is for Lance and Brennan, and that is, what do you recommend as a vapor barrier at insulation joints?
So I'll take that one for the duct wrap side. So on the duct wrap side, when you join two sections of duct wrap together, or you're bringing them together, you're going to tape that together, and that tape will have the same vapor barrier. Usually it's made of the same FSK facing or PSK facing that your duct insulation is made together. There's a staple flap that comes from the factory that allows you to overlap that joint and put the two pieces together. You'll want to tape that down and squeegee over it. You can also use mastic over top of that if you'd like to, but that's going to provide you with your vapor barrier on a duct wrap project.
Yeah, it's really the same answer for pipe insulation. Pipe insulation comes with joint tape called butt strips that's made from the facing that's identical to the fiberglass pipe insulation facing. And then, with additional joints, there's rolls of tape that are available that matches the facing of the pipe insulation. And then on chilled systems, it's very often over those joints that you'll apply mastic as well.
Great, thank you guys. Scott, the next question is for you, and that is, do you have any details about applying mastic on duct wrap? Anything they should know?
Follow the manufacturer's installation instruction. It's commonly, and a lot of government specs require you to put down a tack coat of mastic and then embed a cloth in it, and then go over with a top coat. And that's a very common application we see. It's part of the old master spec, and it's in many of the military and government type specifications.
Excellent, thank you. Lance and Brennan, the next question is for you, and that is, what are your thoughts on fire ratings for your insulation systems?
Yeah, so for pipe insulation, we're trying to meet a common code requirement from ASTM E84, which is a flame spread and smoke development, and our insulations are rated at a 25 flame spread and 50 smoke development. So in many applications, that's all that's required for commercial code requirements.
Yeah, I would say the same thing. Everything is tested to E84. Duct wrap is tested to E84, the 2550 rating, so that everything meets that fire and smoke rating.
All right. The next question is, do you have any thoughts about mold management within your systems? And Lance, this came through during the chilled water portion, so we'll start with you.
Yeah, that's really where you're focused on preventing condensation. The mold, one of the key components for mold growth is that there's moisture present. So preventing condensation is the most direct and applicable way of managing mold, is preventing it from occurring in the first place by keeping moisture unavailable to it.
Scott, do you have anything to add to that?
Yeah, as far as the duct sealants and the insulation mastics, again, choose a quality product. Anything water-based should have a biocide in it to prevent mold and mildew from growing. There's good ones and not so good ones. Again, it's tough to tell or impossible to tell from a data sheet. The one thing I would recommend, which I've seen quite often, is don't leave your brush, don't cut a notch and leave your brush in a bucket of mastic with or duct sealant. I've seen many brushes are made from hog hair and from wood, which are both food for mold. Keep them out of the bucket. Our DP 1010 or DP 3040 in our full line have a very good biocide in it, and it will prevent the mold and mildew from growing on the sealant. But an inspector coming by and seeing a hairy green brush is a good way to get flagged on the job.
Excellent. Brennan, do you have anything to add?
And I'll add to that, and I know we didn't in this webinar, we didn't go into internally lined ducts relative to lining on the inside of sheet metal ducts, and there's a lot of information about that as well as on JM, but all of our products, our Line Acoustic RC duct liner product or our Spire Acoustic Plus product, for example, we do a permacoat acrylic coating on our Airstream surface, which has an antimicrobial built into that coating itself as well as into our glass mats. And it also has water repellency built into that as well, so if you're getting any condensation coming off of that fan, it will actually bead up and sit on the surface until it dries out through that Airstream and inside of the duct itself. So I know we didn't touch on that today, but there's a lot of information that we have available on our permacoat coatings for our internally lined systems.
Excellent. Scott, we had a follow-up question to your comment about the mastic on duct wrap, and that is, do you always need the screen cloth tape on duct wrap joints before applying the mastic?
You don't always, but it's very typical in specifications.
Okay. The next question is also for you, Scott, and that is, some contractors have proposed in Design Assist project to use tape in lieu of mastics. Is tape sufficient for a seal in all instances?
Well, I'll clarify tape. Foil mastic tape, like I briefly discussed with our DP 240 and 340, yes. Now that tends to be much more expensive than your typical duct tape or your foil tape. And the very short answer is foil tape or any type of duct tape is not a replacement for mastic. There was a study done years ago by Lawrence Berkeley or Lawrence Livermore Labs that tested all types of duct tape, and they found that every duct tape they tested failed and failed catastrophically, usually at a matter of a couple months. The adhesive in those duct tapes becomes brittle with temperature cycling, which is exactly what a duct system does. So the international energy codes are in the process and have been in the process of not allowing duct tape as a duct sealer.
Okay, and then we have one final question, and that is what insulation sealant is recommended for chilled water pipe that's in service?
In service, our DP 3040, but I can't give you a definitive answer on that because we have not tested the perm rating while it's curing. Maybe Lance can address putting the tape on it and sealing it from the outside.
Well, you kind of touched on that earlier, Scott, when you said you wouldn't recommend trying to seal something that's in operation. And I guess that's my gut reaction to that question. It's kind of an unknown territory because we tend to think of our systems being installed when the chilled system's not in operation. I know as a practical matter, I'm sure it happens and people run into it, but maybe that's something we need to think about more here at JM of how we might help address that. So I'll keep that in mind.
Yeah, I do not have a recommendation for that.
Okay, and sorry, we had one more question come through, and that is, I am interested in the black duct wrap. When will you be releasing it?
Good question. My target launch date is June 1st to have it available. So it's probably another 4 or 5 weeks away here. So there'll be a whole bunch more information coming out on that here in the next couple weeks.
All right, great. If anybody thinks of any questions that they did not ask or were unable to ask or didn't get answered in this presentation, you can certainly submit them in the survey that we're going to send out here as soon as you close your screen. Otherwise, we thank you very much for attending today, and we hope you found this information useful and relevant. And if you have any questions, please don't hesitate to reach out to any of us, either directly or via the survey that's going to pop up on your screen shortly. Otherwise, take care and have an excellent week.